I'm Ennemcien. We were discussing the dynamics of helical spring. Now we have to see, before concluding the topic, theoretical part of the topic, two more points. Work done. One is work done to compress or extend a spring. Two, potential energy stored in a deformed spring. Of course, you may be familiar with mechanical energy forms. One is kinetic energy and the other is potential energy. When you hear the word kinetic energy, remember this simple concept. If you say a body has a certain kinetic energy, what does it mean? I mean it like this. The body in motion is the body is in motion and is ready to act. That's all. It is in motion and ready to act. It can break down the target to pieces, or it can do any kind of work on other bodies with which it collides. Potential, the word potential means stored or hidden. So potential energy means hidden and ready to act. A body has potential energy means something is hidden in the body and it is ready to act. That's all. If you want to expand or extend a spring, you have to exert effort. In common language and in physics, we will say that we have to do work to extend or compress a spring. The simple formula for this is work done to extend a spring by an amount x or to compress a spring by an amount x is half k x square, where k is the stiffness of the spring. This is the work done on the spring. This work will be hidden, will remain hidden in the spring, and we can restore it for useful purposes. So, restoring force in a spring is Fr equals minus kx. Then spring stiffness and length relation k into L is a constant. Differential equation of a spring is acceleration equals A equals minus k by m into x. Finally, work or potential energy of a deformed spring is half kx square. So these are the basics of a spring system. Let us see a problem, a simple problem. I shall read it. The question. The stiffness of a spring is 200 Newton per millimeter. A 100 kilogram load falling from a height compresses the spring by 10 millimeter. Find the acceleration with which the load begins to rebound. Take small g as 10 meter per second square. This is the question. Simple question. This falling body, mass of this falling body is 100 kg, 100 kilogram. And it compresses the spring by 10 millimeter. That is X equals 10 millimeter. Stiffness of the spring K equals 200 Newton per millimeter. That means the restoring force developed in the spring caused by the fall of the load is minus kx. Just to avoid that minus sign and find the magnitude as kx. So here it is 200 into 10. 200 is in Newton per millimeter into x is in millimeter into 10 millimeter. So millimeter and millimeter would go, then you will get as 2000 Newton. That is the restoring force. This restoring force, since it is being compressed, the restoring force is vertically up, acting on the load. 200, so the spring pushes the load up with 2000 Newton force. In addition to this force, there is another force acting on the load, that is its own weight, W. Weight of a body is mg, mass into acceleration of free fall, mg. That is, here g is given as 10. That means weight of the body is 100 into 10, 1000 Newton. This 1000 Newton is vertically down. Force from the spring is 2000 Newton vertically up. So the upward force is greater than the downward force. So the resultant or excess upward force is 2000 minus 1000. That is 1000 Newton. So by the impact, the load receives an upward resultant force of 1000 Newton. This causes a definite acceleration. You can find out it using Newton's second law, force law, F equals ma. So that acceleration A equals F by m. That is 1000 by mass of the body is 100 kilogram. But 1000 by 10. 100. 1000 by 100 equals 10 meter per second square. That is the acceleration received by the load from the spring. Thank you.